Lesson 4.4 is on proving triangles congruent using SSS and SAS. In the last lesson, we could prove that two triangles were congruent if all of their corresponding parts were congruent. So that meant if all of the corresponding sides were congruent and all of the corresponding angles were congruent. However, it is possible to prove congruency with fewer parts. The first is the SSS postulate. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. And as you can probably figure out, SSS stands for side, side, side. So, here we have triangle ABC and triangle DEF. If AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then triangle ABC is congruent to triangle DEF. Let's take a look at how we might use the SSS postulate in a proof. Here we're given isosceles triangle ABC with base AC and BD bisects segment AC, and we need to prove the triangle ABD, so the smaller triangle on the left, is congruent to triangle CBD, the smaller triangle on the right. So let's go ahead and state just the first part of our given, that we are given isosceles triangle ABC, and that's given. Now, because it's an isosceles triangle, I know that two sides are congruent. So I'm going to actually go ahead and mark those. I know that AB is congruent to CB. And I can say that AB is congruent to CB, and that's by the definition of an isosceles triangle. Definition of an isosceles triangle says it's a triangle with two congruent sides. Next, I think I will state the second part of my given. BD bisects segment AC, and that is given. So if BD bisects AC, that means that segment AC is cut into two congruent parts. So AD is congruent to CD. So segment AD is congruent to segment CD, and that's by the definition of a segment bisector. A segment bisector cuts a segment into two congruent pieces. Okay? Now, one thing I'm noticing is that segment BD here is congruent to itself. So I can say segment BD is congruent to segment BD. And that's our friend, the reflexive property. Now you're probably wondering, why do I have to say that? Well, it's pretty obvious that I'm going to be using the SSS postulate. And I actually have to state in my proof, I have to state that here's a side, and here's a side. I have to state those three sides are congruent, so that means I do have to state the reflexive property, that segment BD is congruent to itself. And now I can say the triangle ABD is congruent to triangle CBD by the SSS postulate, or you can just write SSS. We also have the SAS postulate. And notice that the A, which you probably figure stands for angle, is between the two sides. That A is between the two sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. And let's take a look at this picture. So in this picture, angles A and D are the included angles because they are formed by the pairs of congruent sides. I'm given that AB is congruent to DE, AC is congruent to DF, and notice angle A is between those two sides and angle D is between those two sides. Angle A is included between the two sides and D is included between the two sides. So if those corresponding sides are congruent and the included angle between them are congruent, then we can say by SAS that the two triangles are congruent to each other. Let's take a look at how we might use this in a proof. We are given that AB is congruent to CB, and I'm going to go ahead and mark that. AB is congruent to CB, and we're also given that segment BD bisects angle ABC. So let's go ahead and state that AB is congruent to CB, and nothing I can really build off of that, so I think I'll include the other part of my given in here as well. BD bisects angle ABC, and both of those are given. Now, if segment BD bisects big angle ABC, then that means that this angle ABD and this angle CBD are congruent to each other. So angle ABD is congruent to angle CBD by the definition of an angle bisector. Okay, and since I know I'm probably going to be using SAS, since that's what we just talked about, I'm seeing an angle, or I'm sorry, a side, and then I'm seeing an angle, and I will use the reflexive property again to say BD is congruent to itself. Segment BD is congruent to segment BD by the reflexive property. And let's go ahead and mark. So here I have a side, here I have an angle, and here I have a side. So I can now say that triangle ABD is congruent to triangle CBD by SAS, side angle side. And let's take a look at one more proof here. It's given that AB is congruent to CB, so I will mark those. Oops, so I keep that. It's also given that AD is congruent to CD, so I will mark those. And what I have to prove is that angle ABD, so that's the small angle at the top on the left, is congruent to angle CBD, which is the small angle up on the right. Now, what is different about this proof is if you look back at our last two, what we had to prove was that two triangles were congruent to each other. In this case, it's not asking me to prove that two triangles are congruent, but instead prove that two angles are congruent to each other. So this is where we're going to use what we learned in the last section, CPCTC, that corresponding parts of congruent triangles are congruent. In other words, if I can prove that these two smaller triangles are congruent to each other, then I can say that any of their corresponding parts are also congruent. Okay, so let's dive in. Let's go ahead and state our given. AB is congruent to CB, and AD is congruent to CD, and that's given. The other thing I'm also noticing is that segment BD is congruent to itself. So let's go ahead and state that. And that's by the reflexive property. And you'll notice from the diagram what I've marked, and also from our statements, that we have an S, and here's another side, and then here's a third side. So we actually have three sides of one triangle being congruent to three sides of the other triangle. So I can say that triangle ABD is congruent to triangle CBD by SSS, because the three sides of ABD are congruent to the three sides of CBD. And now, because those two triangles are congruent, all of their corresponding parts are congruent. So in other words, angle A is congruent to angle C, angle BDA is congruent to angle BDC, but the ones we're interested in are these angles at the top. So I can say that angle ABD is congruent to angle CBD by CPCTC. Corresponding parts of congruent triangles are congruent. Because these two triangles are congruent, all of their corresponding parts, including these two angles, are congruent to each other.